Given a cubic polynomial p of x, for part A, find the quotient when p of x is divided by 2x plus 3 and show that the remainder is negative 6. If you look at the divisor, you have a 2x plus 3. I would suggest you do not use synthetic division if you are not familiar. Let's just do a long division then. We have 4x cubed plus 16x squared plus 9x minus 15. 4x cubed divided by 2x, that is 2x squared. Now let's take 2x squared, multiply throughout by the divisor. That is 4x cubed plus 6x squared. Now we subtract 4x cubed minus 4x cubed, that is gone. 16x squared minus 6x squared, that is 10x squared. Bring the rest down, 9x minus 15. 10x squared divided by 2x, that is 5x. 5x times 2x plus 3 is 10x squared plus 6x. So now, 15x. Now we subtract 9x minus 15x is negative 6x. Bring the negative 15 down. Negative 6x divided by 2x is negative 3. Multiply 2x plus 3 by negative 3, and we have negative 6x minus 9. When we subtract minus 9 from negative 15, that is a negative 6. From here, we can see that the quotient is 2x squared plus 5x minus 3. So this part is the quotient. And negative 6 here is the remainder. Part B, to integrate p of x over 2x plus 3. From part A, when p of x is divided by 2x plus 3, we have the quotient, which is 2x squared plus 5x minus 3, and the remainder is negative 6. So we are minus 6 over 2x plus 3. In order to integrate p of x over 2x plus 3, we just integrate the right side here. So we integrate 2x squared plus 5x minus 3 minus 6 over 2x plus 3, and we integrate this with respect to x, term by term. The first term upon integration is 2 over 3x cubed. The second term, 5 over 2x squared minus 3x minus 6. 2x plus 3 is in the denominator, so the antiderivative or the integral must be a log function. So we multiply by 1 over 2 log of the absolute value of 2x plus 3 plus a constant of integration. And we can rewrite the first part and only simplify this part. That is negative 3 ln of the absolute value of 2x plus 3 plus c. That will give us the integral. Part C, we are to factorize px plus 6 completely. And then we solve this equation. Yeah, for x in between 0 and 135 degrees. Answer is in degrees. Now, if you look at px plus 6 here, from this statement, we can rewrite the division statement so that px is 2x squared plus 5x minus 3 times 2x plus 3. And then we have a negative 6 here. We bring this negative 6 over to the other side so that px plus 6 is 2x squared plus 5x minus 3 times 2x plus 3. This is a quadratic that can be factored. So we have 2x and x. Then we have 2x plus 3 plus 5. So this must be a 3. This is a positive. That is a 1 and a negative. Then we have already factored px plus 6 completely into linear terms. We need to solve for p of cosecant 2 theta plus 6 equals 0. But if you look at these parts here, if you can actually let x to be cosecant 2 theta, then when you want to solve for p of cosecant 2 theta plus 6 equals 0, that is the same as replacing x with cosecant 2 theta into these linear factors and set them to 0. Now remember that your answer is in between 0 and 135 degrees. So for this case, when we set this to 0, we are actually setting 2 cosecant 2 theta minus 1 times cosecant 2 theta plus 3 times 2 cosecant 2 theta plus 3 equals 0. This is what we are solving. Setting each linear factor to 0, we have to set each of these to 0. 2 cosecant 2 theta minus 1 equals 0. Isolating cosecant 2 theta, that is 1 over 2. Yeah, cosecant has a value, takes value that is greater than 1 and less than minus 1. A 1/2 is just not possible. This will not give us a solution, so we are done with that thing. But let's just forget about it. Second linear factor, we have cosecant 2 theta plus 3 equals 0. Cosecant 2 theta is negative 3. Cosecant is the reciprocal of sine. We have sine 2 theta equals negative 1 over 3. Now, we need to find the reference angle. So we find the inverse sine of 1 over 3 for the reference angle. And that is 19.47 degrees in degrees. Sine is negative in quadrant 3 or quadrant 4. Remember that your angle must be in between 0 and 135 degrees. So we do not actually need the quadrant 4, don't think so. Then 2 theta here. For a quadrant 3 angle, this is the argument 2 theta. Quadrant 3, we have 180 plus 19.47 degrees. And then we divide this result by 2. So if you imagine a quadrant 4, you will not end up within the range of the required answer. So yeah, let's just forget about that. That will give you 199.47 degrees. And divide this by 2 to obtain the value of theta. That is 99.7 degrees. That is one of your answer. It's within the range from 0 to 135 degrees. We still have the third linear factor. Set this to 0, 2 cosecant 2 theta plus 3 equals 0. Isolating cosecant 2 theta, we have negative 3 over 2. Converting it to sine, sine 2 theta, you just flip the right side and you're good. Keep the negative. then the reference angle is the inverse sine of 2/3, and that should take a value of 41.81 degrees. Again, sine is negative in quadrant 3 or quadrant 4. We do not need a quadrant 4 angle because of the restriction to your answer. Yeah, we just use a quadrant 3 angle. So we have 180 plus 41.81 degrees. That is 221.81 degrees. And dividing by 2, we have 110.9 degrees. So these are the two answers with in between 0 and 135 degrees. And we are done.